Good afternoon, everyone. Welcome. My name is Winnie Armand, and I am an Associate Director at the Center for Environment and Health at Mass General. Thanks for joining us. We have our monthly webinars that feature experts who discuss the intersections of climate, environment, and health. This series is co-sponsored by 3 organizations, including the Mass General Center for the Environment and Health, the Institute of Health Professions, the Center for Climate Change, Climate Justice and Health, as well as the Brigham and Women's Hospital. It's a treat today to have with us my wonderful colleague at MGH, Dr. Tina Duhame, who is also faculty at the Harvard University Center for the Environment, otherwise known as HUSE. She's a personal fan of our guest speaker, Dr. Dan Schrag, today, and so she'll introduce him on our behalf.
Thank you, Winnie. It's my absolute pleasure to finally have gotten Dr. Schrag to give a talk to us, because I think he will elucidate things that take many of us a long time to learn. By way of brief background, he is the Sturgis Hooper Professor of Geology at Harvard and also Professor of Environmental Science and Engineering. He co-directs the program on Science, Technology, and Public Policy at the Belfer Center for Science and International Affairs at Harvard's Kennedy School. He got his undergraduate degree at Yale and his PhD in geology at University of California, Berkeley. And he has a long, long list of accolades, awards, and expertise panels that he's been on, including President Obama's Council on Advisor for Science and Technology, a MacArthur Fellowship. And I got to know Dan because of his directorship of the Harvard University Center for the Environment. I can characterize Dan as a global, broad thinker, and he knows virtually everything there is about climate change, policy, science, and the intersection of these. And he casts a really wide net in the people that he recognizes are really concerned about this problem, even people like neurosurgeons like myself, and he brings everybody in under the same tent to go at these very complicated problems from multiple directions, including the arts, literature, the law, you name it. Dan has connections to people who know about that subset of the concern for environmental problems. So he's going to talk to us about really, where does clinical medicine, which most of you in this audience participate in, where does this fit into the big picture? And I will tell you that we all stay pretty narrow in our lanes, and we approach problems that we can see in front of us. The reason that I thought Dan would be an excellent speaker for this series, that he will give us the big picture and how we may or may not fit in. So without further, I will give it over to Dan. Thank you.
Wonderful. Tina, thank you. I've got to say thank you to Winnie and to you and to all the people at MGH and MGH Brigham who are involved in this. I think it's so inspiring and important that those of you who work in the trenches in clinical medicine actually have the energy and curiosity and time to think about these issues. And so I applaud all of you and really appreciate your engagement on this. So what I'm going to try to do is give you, as Tina asked for, a really broad picture. I want to give you a sort of a broad picture of how I think about the climate problem. We could spend hours on this. We could spend, I teach an entire class and it feels like it's a sprint. There's not enough time to do anything. I'm going to try to do all of that in about 25 minutes and then talk a little bit about this question of what's the role of clinical medicine. And there, I'm really out of my league. I don't know what the right answer is. I will talk about a few ideas, and then maybe Tina and I will have a conversation a little bit to digest those ideas and see how people react, and then we can focus on that in the question and answer session. So what I'm going to do is first give you a very high level view of the climate problem, and then we'll get into more details. I'm going to share my slides here. Okay. Okay, can everybody see the big globe? Okay, that's just a sign to get going. So again, this is going to be a little bit of a romp through this problem because we don't have time to go into a lot of detail, but I do want to give you a high level sense of what's going on. The Earth is warming up. This is global temperature, multiple groups around the world, including this one from the UK Met Office, but there's NOAA in the US and NASA in the US and other groups, all pretty much agree. The Earth is warmed by something like 1.1 degrees, 1.2 degrees over the last 130 years or so. Exactly what the baseline is debatable. That's why there's a little bit of uncertainty here. But there's no question the Earth is warming, and there's lots and lots of evidence to show that it's unprecedented. What some people may not know is that the science of climate change goes back a very long way. John Tyndall in the mid-19th century described the greenhouse effect. He did these elaborate experiments in front of big audiences to show how different gases, including carbon dioxide, absorbed infrared radiation and how that was involved in warming the planet. And then Svante Arrhenius, who was the first Swedish Nobel laureate, won the Nobel Prize in Chemistry in 1903. He was a physical chemist, and this is a picture of him, Svante Arrhenius. 1896, he wrote this paper on the influence of carbonic acid, which is carbon dioxide, in the air upon the temperature of the ground. And in a popular book that he wrote a few years later, he calculated that for a doubling of carbon dioxide, which he thought humans could do because they burned enough coal. At the time, it was really dominated by coal. This was before the big rise of automobiles and before natural gas was a big deal. That it would roughly increase the temperature of the Earth by 4 degrees Celsius. Not bad for 1896. The truth is, we think it's probably closer to 3 degrees, but given what the tools that he had, it was pretty impressive. So this is an old problem. It's not a surprise. What is maybe more important to appreciate is that since that time, CO2 has nearly doubled. So this is the Keeling curve. Dave Keeling started measuring carbon dioxide in 1958 when it was about 315 parts per million. He died in 2005 when it was about 380 parts per million. His son continues these measurements today. This is from Mauna Loa, Hawaii, where it's far from any local sources of pollution. And we're now well above 420 parts per million. Pre-industrial level was 280 parts per million. But to me, as a geologist, this curve doesn't really explain what's going on. We know carbon dioxide is the main greenhouse gas. There are other greenhouse gases as well. But the important thing is, to me, this is the way I see the Keeling curve. This is now 800,000 years of carbon dioxide in the atmosphere measured from an ice core from Antarctica, or from a couple of different ice cores from Antarctica. You see these natural fluctuations. These are actually correlated with the ice ages coming and going. So 20,000 years ago, right here, 20,000 years ago, this was when Boston was covered by about 1 kilometer of ice. There was so much ice on land that sea level was about 130 meters lower. CO2, carbon dioxide levels, were part of the explanation of why it was so cold. They were about 180 parts per million. These fluctuations are due to internal cycles in the Earth, but carbon dioxide plays an important role in amplifying those variations and creating the climate. And just to give you some perspective, the global temperature 20,000 years ago during the last glacial maximum was about 5 degrees colder than it was in the pre-industrial level. So we're talking about potentially seeing 5 degrees of warming over the next 100 to 150 years. But understand that the warming from the last glacial maximum 20,000 years ago looks pretty fast on this graph, but it occurred over 10,000 years. What we're doing now is happening in a century or two. It's like 50 to 100 times faster. And rate is everything. If climate change was happening over the next 10,000 years, we probably wouldn't be talking about it right now. The fact that it's happening so quickly is really important. And this recent rise is just literally over the last 100 years. We've seen this extraordinary rise in CO2. That's what's driving this. And again, for more than 120 years, we've known that this is going to warm the climate. When I talk to broad audiences, I want everybody to understand why this is such a difficult problem. It is, in my view, it's the hardest problem the world's ever faced. And that's for two simple reasons. One, it's a collective action problem that is global, and we'll come back to this later. The key is that the atmosphere mixes, that the Earth system doesn't care about US emissions or Chinese emissions or African emissions. It cares about global cumulative emissions, and we'll come back to that point later. I should point out that it's global, but not equal. And that's really important. This is a graph showing the cumulative CO2 emissions from fossil fuels and also from land use, deforestation, agricultural clearing of land, et cetera. You can see that the US as a country is just way ahead of every other country in the world. China has roughly half. Europe combined comes close, but not quite to what the US has contributed over the last 150 years or so. And so, you know, I'll come back to this point, but climate, what I call climate injustice, because climate justice is a perverse oxymoron. Climate change is the most unfair phenomenon because many countries will suffer who didn't contribute much to the problem at all. That's just the structure of the problem. But the other reason why climate change is so painfully difficult is that almost every aspect of climate change has really long timescales. And when I say long, I mean, I'm talking as a geologist when I say long. I want to play this movie for you. This is a movie showing the spatial footprint of climate change. So this is, think of this as the geographic pattern of climate change. What it is it's a 5-year averages of temperature. And this is to smooth out year-to-year variations and seasonal variations. It's looking at 5-year averages. You don't see much until the 70s, but now over this next period, you're going to see pretty rapid warming, and you're going to see a pattern. What you notice, first of all, clear the Arctic is warming a lot more than the rest of the world. What I hope you can also see is that the land is actually warming a lot more than the oceans. In fact, if we look at temperature of the oceans and the land separately, so this is global surface temperature from 1950 to 2020, and you see that the land is warmed about twice as fast as the ocean. And this is actually exactly what you would expect from the basic physics of climate change. The reason is the oceans are a giant heat sink. They're mixing, whereas the land doesn't mix. So the oceans, because of the winds and the tides, are mixing downward and bringing colder water back up. So essentially, the radiative imbalance caused by adding greenhouse gases to the atmosphere is causing essentially the surface of the Earth is trying to radiation or heat. The greenhouse gases have caused an imbalance by absorbing some of that heat, and the Earth's trying to heat up to create a new balance. And what we're seeing is that the oceans are sucking up that heat and mixing it downward. That's good. That's actually preventing the Earth from warming as fast as it would if the whole Earth were made of land. But the bad part is that we're committed already to the oceans continuing to warm for probably 500 to 1,000 years. That is, the timescales of just the ocean mixing are millennia. And so we've already set the Earth into a process of warming that will continue not just for our children and grandchildren, but for literally generations into the future. This August, I was in Greenland. This is as close as I got to the Greenland ice sheet. The Greenland ice sheet is amazing, but it's also melting. It's losing 300 billion tons roughly per year. This is data from a satellite called GRACE that measures the gravitational field of the Earth, so it can actually measure the mass loss in Greenland. To understand what 300 billion tons of ice is, think about 300 cubic kilometers of ice. So think about a piece of ice, a kilometer high, 30 kilometers wide, and 10 kilometers long. That's how much ice is being lost from Greenland every year. The good news is it's a trivial amount of ice. It's only 1/7,000th or so of the Greenland ice sheet. Greenland has about 7 meters of sea level equivalent stored on it, and sea level from contribution from Greenland is just a little less than a millimeter a year. So it's not that much right now. The scary thing is that it's accelerating. And the time scale of these ice sheets, we don't know. We hope they're really long, but it could, if it's only centuries, then we've got a big problem. Sea level today is globally is raising about 3.5 millimeters a year. And the big question is, how much will it accelerate into the future? Again, there's a question about inertia in the system. As the Greenland ice sheet melts in the summer, its elevation lowers, and there's a feedback just because of the lapse rate in the atmosphere. It gets colder as you get to higher altitude. So as the ice sheet elevation lowers, it gets warmer. That's a positive feedback. And so we may actually hit a point where essentially it's not like Greenland will melt instantly, but we've already set it on its ways such that future generations will inevitably have to deal with rising sea levels for many, many centuries into the future, because we've essentially taken the cork out of the bottle. And this is also true in Antarctica. I'm not going to talk about Antarctica, but in some ways Antarctica is even scarier because it's not melting per se, but it's breaking up because of interactions with the warming ocean at depth. And it's very hard to reverse those changes. Once some of the ice shelves break off in Antarctica, it's just a physical gravity effect. Essentially, the ice in Antarctica is going to flow downhill into the ocean and raise sea level, and there's almost nothing we can do to stop it. I'm going to skip some of this just because we're going to take too long, but I just want to point out that long time scales are everywhere in the climate system. You know, half of the CO2 that we put in the air is taken up by the ocean and the land, but half of what's left is going to still be there 1,000 years from now, and a third of that is going to be there 20,000 years from now. So we're making decisions today that will affect the Earth literally for tens of thousands of years. We haven't even begun to think about how to deal with those kind of timescales. Humans are inherently tribal. We're bad at collective action, and we're also really bad at long time scales. And there are all sorts of surprises. This is just a picture of a big scarp in Siberia. There's a lot of organic carbon in the soils of Siberia because it's frozen. The permafrost can be 20 or 30 meters thick. And as the Earth is warming, the permafrost is thawing, and the carbon that was frozen becomes available to bacteria and fungi and is turning back into CO2. And we don't know exactly how much carbon there is there, but we think there's enough organic carbon there roughly to produce roughly 2 trillion tons of CO2. Just to give you a sense, that's about as much CO2 we've produced from cumulative fossil fuel burning from the beginning of the Industrial Revolution. So there are systems like the permafrost in Siberia where we could literally lose control. That is, the Earth system could start releasing carbon to the atmosphere, and no matter what we do with emissions from fossil fuel burning, a massive amount of additional warming could occur. This is a really complicated system, and it's hard to predict how it's going to occur. But, and this may be the darkest part of this talk, the timescale of energy systems, unfortunately, involves other long timescales. You know, in the political realm, the environmental advocacy realm, we hear about aspirational timescales for decarbonization, for transforming our energy system. In my course that I teach this afternoon at 1:30 on climate change to about 200 students from all over the university, I make them design a low carbon energy system for the US, and then we talk about the whole world. And the reason is, if I were to just lecture as I'm doing now and tell you that decarbonization is hard, you might think of it as my opinion. Whereas if you actually do the calculations yourself, you begin to realize how difficult it really is. The fact is, the timescales for actually decarbonizing our entire energy system, maybe technically on paper, you can figure out that you could do it in 10 or 20 or 30 years, but it seems incredibly unlikely to actually happen. And again, I don't want to spend a lot of time on this, but I want to just give you a couple of perspectives on why this is so challenging. Here is a picture, by the way, of world CO2 emissions over the last 50 years or so. And what you see is, Chinese emissions are still going up. Other countries' emissions are still going up. Indian emissions are still going up. The EU, and this is, I think, before Brexit, so this is the EU, including the UK and the US, they're slowly coming down. The European emissions have been coming down for a very long time, but very slowly. And then there's lots of countries in the rest of the world where emissions are going up, but many countries, their emissions still aren't going up because they're still so poor. And they want to be able to have the same kind of emissions and the same kind of economic activity that we have. So there's a huge issue of fairness and equity here that is inevitably a part of this. There's some really good news. Wind has gotten super cheap. Solar has gotten super cheap. And that's a really important thing. And this is just an example. This is from 2021. It's roughly 3/4 of the new electricity capacity installed in the US for the last several years has been wind and solar. That's incredibly exciting. This was, by the way, during the end of the Trump administration, and Donald Trump had a huge hatred of wind energy. And yet wind and solar still dominated the electricity in terms of new installations. Just tells you that cost trumps politics in a certain way. That's very exciting. Of course, we have to understand that overall, the US still only has 14% wind and solar penetration. Spain has about 40%, so does Germany. Ireland has about 40% wind. We have a long way to go. We probably have 2 decades of building wind and solar at the current rates we're building it, just to get to where Ireland and Spain are today. So the idea that we're going to do all this in the next 10 or 20 years doesn't seem very realistic, at least not with the level of political will we have now. A view that you hear from Silicon Valley might be that it's just going to be technology that's going to come and solve the problem. And in one way, this perspective is right. Technology is critical to a solution. So, for example, when electric vehicles become cheaper than internal combustion engine vehicles, which is actually coming very close, I wouldn't be surprised if in the next 5 years, the total cost of ownership of an electric vehicle is lower than an internal combustion engine vehicle. And then people will buy them without policy. You don't need to twist people's arms or twist countries' arms to buy electric vehicles because they're better and cheaper. Why wouldn't you build it? Same with wind and solar. When wind and solar are cheap enough that they're the cheapest and best choice, then you're going to build wind and solar. Why would you waste your money building coal or natural gas? In reality, it's more complicated than that because wind and solar are intermittent. And so above a level of 40 or 50%, or maybe 60%, we don't know, it becomes really difficult to manage wind and solar on the grid. And so cost of storage is really expensive. This is where the energy community is focused right now, trying to manage the intermittency and higher penetration of wind and solar. But right now it doesn't look easy and it doesn't look cheap. And I'll just give you one example, just to underscore what we're talking about. This is from a study my friends at Princeton did on zero carbon energy system for the US by 2050. This shows the transmission capacity in the US, roughly 320,000 gigawatt kilometers. Don't worry about gigawatt kilometers, is just a rating of how big the transmission line is. Just think of it as kilometers. But 320,000 kilometers, that's what we have today. And what they calculated for one of their scenarios that was pretty heavy on wind and solar, they would have to build an additional 1.3 million kilometers of transmission, roughly 400% of what we have today. They estimated a cost of $3.5 trillion. I actually think that's a very conservative estimate. I think it could be double that. And but here's the important thing. You might ask, how much are we building today? And the answer is about 2,500 kilometers a year. So understand that at the current rate of construction, this kind of transmission investment represents like 600 years of construction. Now, could we build it faster? Of course we could. But understand that we have 50 years of between Boston and Quebec to get hydropower from Quebec. And New Hampshire and Maine and Vermont have refused to build it because they don't want the transmission lines. Bernie Sanders wants a Green New Deal, but he doesn't want to let transmission lines through Vermont. So this is a problem. We really, is this technically possible to build a transmission system like this? Absolutely. Is the political will available to essentially mandate it without local communities objecting to the transmission lines? Not under the laws we have now. And it's really hard to imagine how we get from here to there. So I don't want to be too depressing. I just want to say that the political aspirations of politicians that we're going to decarbonize in 20 or 30 or 40 years, they don't look very realistic to me, at least not at the level of political will we have now. I want to come back to this point that I made earlier, because I think it's really important. The climate system responds primarily to cumulative global emissions. So that means the goal must be net zero for the world. But what matters, that doesn't mean that net zero for individuals or institutions is actually significant. That's just a number. What really matters is how we are moving the world towards global net zero. That's what really matters. And that's what I want to talk about in a little bit. So for example, decarbonizing the US or Europe as quickly as possible is not the goal. And I think the Sunrise Movement, my friends, young people who fantastically protested and came up with the idea of the Green New Deal and got so much political traction and in some ways restarted climate, at least in the Democratic Party, as a major issue, raised the profile. I think they did an incredibly good job. But the conception of the Green New Deal is that the goal is to decarbonize the US as quickly as possible. And that's actually not the goal. It's decarbonizing the world. So leadership means getting others to follow. So decarbonizing the US isn't what's critical. It's decarbonizing the US in a way that looks attractive to other countries. If we just spent a lot of money and ruined our economy and decarbonized the US, other countries would run the other way and we would actually make the problem worse. And so sometimes we forget that in fact, this is such a hard problem because we do have to get all the other countries to participate. And the inequality in this problem is huge. Again, this is another way of looking at global CO2 emissions. This is just from fossil fuel. You see the US is responsible for something like 25%. The EU is 22%. China's a little less than 13%. I want to zero in on the bottom quarter of this graph, though. Take a look at the blue section. Other than South Africa, which is about 1.3% by itself, and if you remove North Africa, so Egypt, Algeria, Libya, Morocco, and Tunisia, sub-Saharan Africa minus South Africa cumulatively is less than 1% of cumulative CO2 emissions. So the whole idea of telling African countries to reduce their emissions or come up with a nationally determined contribution to stabilize their emissions is totally absurd. The idea of the US pushing poor countries to limit their emissions is so fundamentally unfair, and yet that is the nature of the global climate discussions. And I think it's going to start blowing up actually pretty soon. We'll talk about that maybe a little bit at the end. Again, this question of climate injustice, it's fundamentally unfair, and there's multiple components of it. There's domestic inequality, there's international inequality, there's also intergenerational inequality, and that's maybe one of the most interesting and difficult things to deal with, but it's something that's important. So let me just step away from this point about decarbonization, and just to say that if this is true, if I'm right that global decarbonization is going to take a lot longer than some of the timescales people talk about, then people's experience of climate change impacts are going to grow. That's just logical. Climate is going to keep warming, and we're going to start seeing more and more. Even 10 or 20 years ago, people thought of climate change as something that was affecting people across the world in Bangladesh 50 years from now. That's not true anymore. People actually are aware of how climate change is affecting them today. Arguments about attribution are much less than they were 10 or 20 years ago. So this is changing, and I think it's going to change even more. Hurricane Harvey, for example, just a few years ago hit Houston. It wasn't such a big storm, but it parked over Houston and it rained in some parts of Houston 60 inches. 60 inches in just a couple of days. That's biblical. I mean, that's just crazy. In fact, intense rainfall is one of the predicted local intense rainfall, more higher rain rate, not overall global more rain, but more intense rainfall events is one of the predicted impacts of a warmer climate. What Houston suffered was extraordinary, but a lot of people don't know very much is Zhengzhou. Zhengzhou is maybe one of the biggest cities in the world that you've never heard of. It's about 12 million people, which I guess isn't that big for China. But in July of 2021, last summer, there was, this is a meteorological map, and you can see there was an intense rainstorm. Here's the rain distribution in Zhengzhou, and you can see in this 1 hour, so it got a lot of rain overall, about 24 inches in a one-day period, but in 1 hour it got 8 inches of rain. 8 inches of rain in 1 hour. The city couldn't absorb that much rain. Just unbelievable, incredible devastation. Like you can't even imagine. And since I grew up in New York City and took the subway to school every day, to me, what really is horrifying is that the subway's flooded. So the subway's flooded, got stuck in tunnels. And this is cell phone pictures of people in the subways as the water got higher and higher and higher, you know, their mouths up towards the ceiling so they could keep breathing. This is what I have nightmares about, because I think it was from my personal experience of my youth taking the subway every day. This is just terrifying. Today in Pakistan, the higher Sindh Valley, sort of the southern part of Pakistan, Sindh Valley is literally underwater, unbelievable. 35 million people have been displaced in Pakistan. And by the way, in Pakistan, the rhetoric in op-eds published in Islamabad say, they did this to us. We are 1% of emissions. They made this happen. So they're quite clear on the attribution point, whatever the scientists say. This is a picture of California. This is the Camp Fire in California that was the deadliest fire. And this is the cover of the LA Times from a year ago, September, or 2 years ago, I think, 2020, September 2020. California, this is the LA Times, California's climate apocalypse. Fires, heat, air pollution, the calamity is no longer in the future, it's here now. This is the press covering what was going on, where people across the Western US just felt terror at the smoke, at the fire, at the risk, blackouts because utilities didn't want us to cause more fires. It was a very scary time. This is Hurricane Michael that hit the panhandle of Florida a few years ago. And I want to show this to you because I want to show you this one house, which was called the Sand Palace in Mexico Beach, Florida. You see this one house right here, it actually came through unscathed. That's because architects designed it to withstand a storm. And I think this points to adaptation as a really important component. Regardless of what we do to mitigate climate change, we need to think hard about adaptation, and we haven't done it enough. We need to think about building codes. We need to think about reforming insurance policies so that we're not encouraging people to live in dangerous places. And we need to think about making tough choices about helping people live and move to more safe places. And that's, of course, really hard, especially for low-income people. In general, the US doesn't seem to have a lot of generosity and kindness in its laws these days and its policies. And of course, countries that are poorer are going to get hit harder. Here's a classic example in Bangladesh showing the impact of sea level rise in Bangladesh. Bangladesh, for people who don't know, is surrounded by hostile countries like India that will not let Bangladeshis across the border, and the Himalayas where they can't go. And so they're really stuck. But Bangladesh is also in some ways inspiring. Bangladesh, in 1991, there was a cyclone. You don't have to read all of this, but this is more to just remind me to talk about it. Bangladesh had a cyclone in 1991. It killed 138,000 people. Unbelievable. And then 3 years later, It was almost the identical storm in 1994. 1994 storm, same track, same landfall location. It killed, it was a lot of damage, but it killed like 350 people. Why the difference? The difference was twofold. One, the Bangladeshi government invested in an early warning system that hadn't existed for the 91 storm. And two, they built a bunch of relatively inexpensive concrete bunkers. And more than 450,000 people evacuated to those bunkers. That's extraordinary. And I think that reminds me, at least, or inspires me, that adaptation doesn't have to be multi-billion-dollar infrastructure. There's a lot of simple, smart, cheap things we can do to protect people. And we have to start thinking about those things. And a group of us last night were talking about how to do this for South Asia, but I think we need to think about this for the US. So I'm going to stop sharing my slides and just talk now to you, Tina, and to everybody about what does this mean for clinical medicine? Just give a few words about maybe 3 different models of the role of doctors. One is the role of a doctor, a physician, as an agent of change, through advocacy. And I think there are a number of concerns I have about that model. First of all, a clinician who advocates for something, especially, unfortunately, something that's been so politicized in the US, that runs the risk of alienating one's patients. And I think many physicians I know, including my wife, who's a primary care physician, would be uncomfortable talking about something that, whether it should be political or not, is irrelevant. If patients feel that it's political, it is a dangerous thing. That's a concern. I would also say, I've heard a lot of physicians try to talk about decarbonizing the healthcare system. And in my own view, that kind of effort on what you might call sustainability, it's very well intentioned. And symbolically, maybe it's a good thing. I tend not to think it's that important. And I know some people will find this controversial, but I think it's for 2 reasons. One is that the whole idea of a carbon footprint, whether an individual carbon footprint or an institutional carbon footprint, I think is a deeply flawed concept. Well-intentioned, but deeply flawed. I don't care what Harvard's carbon footprint is, because Harvard will decarbonize when the world decarbonizes. And the question is the best way for Harvard to lead? Well, Harvard will decarbonize when Massachusetts decarbonizes, when New England decarbonizes, when the Northeast decarbonizes. And the question is the best way for Harvard to contribute to decarbonization of Massachusetts to decarbonize itself in advance of the technology being ready, being cheap? You don't even know what the right technology is right now. And I think there's a balance there. Should Harvard make investments in energy efficiency and maybe spend a little bit more to be as low carbon as they can? Absolutely. I think they should be smart. But remember, money is fungible and money is finite. And so when Harvard makes decisions about where to allocate money, there are choices to be made. And are you going to spend it on decarbonizing, or are you going to spend it in the classroom where you're going to educate students who are going to go out and change the world? And I would argue that there's a balance there, that what we do in our classrooms and in our laboratories is far more important than the slightly more symbolic nature of decarbonization of our campus. Again, should we do some? Absolutely. But I would say that for every dollar we spend on sustainability on our campus, we should be spending $100 on our classrooms and our faculty and actually educating our students and the world. For Mass General and the Brigham, I actually think it's similar, that the role of clinicians is not to advocate on energy technology and energy policy. If individuals want to, that's fine, but I don't think that's where the real influence comes from. I will also point out that sometimes statistics are skewed. I've heard people say, oh, we have to decarbonize healthcare because healthcare is 10% of US emissions. without mentioning that healthcare is also 20% of GDP. And so in fact, relative to other parts of the economy, healthcare overall is half as carbon intensive as the average dollar of economic activity in the US. You know, I believe when we decarbonize vehicles and we decarbonize buildings and we decarbonize our electricity system, healthcare will decarbonize with everyone else. I'm not sure that healthcare demanding clean electricity is likely to accelerate the transition to clean electricity overall for everyone. I know that's a controversial view, but I worry about that. So what is the role then, if not that? I actually think, first of all, the role of clinicians in adaptation is really important. Helping people, and this is sort of like the same as preventative healthcare. It's not something we've done very well, or I would say maybe you haven't done very well as a group. Prevention has not been the strength of the US healthcare system for many years, but it should be its future. And I think for climate change, it's different in Boston than it is from Colorado, and different there than California. You know, if I was a doctor in California, I definitely make sure my patients were prepared for evacuation from a fire if they were living in an area that might burn. I was lived through the Oakland 1992 fire in California and watched that terrifying thing happen. Preparedness is everything, and so physicians can play a role in that. I think that, to me, leads to the final point, which is just that I think clinicians as educators, not that your exam room is a classroom per se, but I do think you inspire, you have trust, you have patients' trust in a way that very few of us do, and you don't need to politicize it. You don't need to tell people what to do, but I think calmly and clearly you can indicate how seriously they can take this problem. And I think that will give us some tailwinds to help solve this problem in the years ahead. So let me stop there. It's 12:43. I want to make sure we have time for questions and some conversation with Tina, and we can talk more generally. Thanks.
All right, great, Dan. Thank you. That, as I expected, gives us a really high-level overview of the problem and the complexity of the problem. So there are some questions in the chat, and I think what I'll do is I'll paraphrase them because they're questions I would ask you myself if we were just having a conversation, and I think I probably have asked you over our conversations over the years. So one is this issue of the correlation between the health effects of fossil fuels in other respects and the whole issue of, you know, climate change. So we already see that fossil fuel use in the communities of the patients that we treat affects their health. So higher rates of asthma, where there are power plants that are fossil fuel generated, peaker plants, you know, neighborhoods where these things are concentrated, and they tend to be the neighborhoods where people have less political voice and so forth. So there has been a push, as you know, in medicine to advocate for decarbonization, not just because of this global problem of climate change, but also because of the more immediate and local health effects of the particulate matters that come along with the fossil fuels. What's your feeling about what physicians' role is in that? So we may not be able to change the global problem, but we may be able to change the problem, or at least advocate for improvement in the problem that affects our own patients.
Absolutely. And I was just telling my class this the other day. So the conventional air pollution, when in the Obama administration, the EPA did an analysis of cost benefits of climate change, and they were constrained to only look at like the next 10 or 20 years because they weren't allowed to look further out. And that means a lot of the scariest things about climate change get left off if you artificially cut off the time scale. But when they did that, what totally dominated the cost benefit analysis was the impact of conventional air pollution. That is not the greenhouse gas component, CO2, but the particles from coal plants, you know, basically getting rid of coal burning power plants and internal combustion engines, including diesel trucks and things like that, that produce all these particulate matters and NOx and lead to ozone. the health effects of that totally dominate the costs of climate change, ironically. So cleaning up the air is fundamentally a good thing. We've done that a lot in Massachusetts already. We don't have any more coal burning power plants, and that's a good thing. But everywhere in the US should be doing that for sure. It's much harder in developing countries where they have millions of, in India, for example, more than 1 million workers, where the railroads, something like 40% of their revenue comes from transporting coal. So just stopping coal is not so easy politically in India. But in the US, absolutely. But again, advocating for that, to whom? Advocating as doctors, speaking out to politicians, as physicians, as trusted members of our community who care about the health of our community. Absolutely, I'm all for that. Speak out, that's great. But advocating to your patients, that's a little more complicated, right?
Well, it is, but I mean, we're in a rarefied environment here. We live in a very blue area, as you know. And I will say that many of my patients, if I have something on the wall about climate change, they'll see it and they ask about it. And many of them actually want to engage in this. So I hear you when you say you don't want to alienate patients who are not aligned politically, but at least here in the community of people that we serve and that are largely our audience for this talk, there are a lot of patients who they actually want advice. They actually want to know. They're all, people are worried about this. So one of the questions that's in the chat is, we can be advocates to politicians. We don't want to alienate patients, but when patients ask us questions and they say, what should I do? People focus on the visible, they focus on recycling, which you and I both know plastics are an issue, but the carbon contribution of that is relatively small compared to other things that could be changed. But when patients ask us, because it's not uncommon that they do, where do you feel that how do you feel we can guide them? Do we basically say, vote, pay attention to your political environment and take a stand and vote? Do we tell them to do things? I hear you about adaptation, but how do we, what's your view of how do you advise people who ask you? They say, hey, Dan Schrag, I went to college with you, you're a climate expert, like, what should I do? What do you tell people and what should we tell our patients?
So I've got to say, I have multiple feelings about this. First of all, I'm very hesitant to tell physicians how to talk to their patients because I'm not one, and I've never talked to a patient in that way. I talk to students, I talk to colleagues, and I talk to students who come to me and say, I really want to change the world. I want to make a difference in climate change. How do I do it? And you know what I actually tell them? I tell them, absolutely, there's many ways to do that. But I say, remember that this problem is going to be with us for a really long time. We're not going to solve this problem in the next 10 years, so you'll miss your opportunity to work on it. This problem is going to be with us, and it's going to get harder, not easier. In fact, the really hard stuff we're going to push off to our children and grandchildren because we'll just do the easy stuff in our lifetime, which isn't actually that easy. So I said, invest in yourself too. Remember that being a student is partly about training yourself so that you're in the best position in the future to have a big impact on this problem. And sometimes the most immediate way to have an impact in the next 10 years or 5 years, if you sacrifice the long term, may actually be a mistake. So don't forget to invest in yourself and invest in making your, a career is a really long thing. And a lot of times the total impact of your career is hard to predict from any one point. So I try to give them, at least help them think about the long view as opposed to, oh, I want to go work for a solar installer and have an immediate impact. I say, what is the thing that you can do that will actually take advantage of your skills, your special abilities, that'll have the biggest impact in the world? I do want to respond to something, Tina, that is in the chat from James McCowan, who's a psychologist, I guess, who says that this is all about behavior. I totally disagree. This is not about behavior, and it is, there's behavioral aspects of this for sure, and we need to think about behavior, but the idea that this is about individual choices and collective behavior, I think a nice example is the pandemic. I think most people would agree that what happened in March of 2020 was pretty extraordinary. People changed behavior because of COVID in a way that at least a week or two before, most public health experts I knew in infectious diseases, who study infectious diseases, like my friend Mark Lipsitch at the School of Public Health, never would have predicted the level of behavioral change, the shutdown that, wasn't perfect everywhere, but we profoundly changed our behavior. We essentially stopped traveling for better part of a year. In the US, that reduced, well, and globally, that reduced emissions by something like 5 or 6%. So I think what that shows me is that behavior, working on trying to get people to change their behavior is not the way to solve this problem. We actually need, behavior will change as prices change and as technology changes, right? Just like cell phones have transformed the way we behave in all sorts of ways. Technology, different energy technology, different energy prices will actually change people's behavior. But the idea that that we focus on the behavior, I actually think is a mistake, and the data suggests the opposite. This, Tina, that I've been working for about 5 years in collaboration with a friend who's John Marshall, who's a advertising executive, and we're working together creating ads to change Americans' mind. We're not focused on ads focused on progressives in Massachusetts, because frankly, they're already supportive. That's not the issue. We're actually going after a lot of other people. For example, we have a whole campaign called Vote Like a Madre, which is focused on Latina mothers who are incredibly movable on climate change. And we don't have me talking to them. We have Jennifer Lopez talking to them. We have Lin-Manuel Miranda talking to them. We have a program focused on suburban mothers in Colorado and Arizona and Pennsylvania and North Carolina. And we have other mothers who are science moms. We have climate scientists who are moms talking to those people about climate change. And I think that part of the behavioral part is important, but that's more, I would say, a political strategy, not a behavioral strategy. We're not telling those people to, focus on their own internal emissions. Again, it's a collective action problem, and it's not going to be solved by individual choices to conserve energy or change, put solar on your roof or something like that. It's much bigger and deeper and more systemic than that.
So when we talk about changing behavior, I think from my point of view, we've had talks about this before, that you could talk about changing individual behavior at the residential kind of family household level, but we can also talk about changing behavior of people who are decision makers, policy makers, politicians, other people who have influence, heads of companies, middle management of big enterprises. And when we talk about changing behavior, really, when I talk about that, I'm talking about changing people's minds so that they make different decisions. And I do feel, and there are some things in the chat about this, when people come to us for advice, there are places where what is in the patient's best interest from a medical point of view also aligns with climate. So a very commonly used example is diet. Right? I mean, it's healthier to eat a plant-based diet. It's also better environmentally. So if as clinicians, we can nudge people towards something that is better for the environment and in fact, better for health, walking someplace instead of driving your car, it's better for your health. So there are ways that we as clinicians can align things that are better on both counts. But I hear you that individual behavior is, relatively small part, depending on who you talk to, of the overall equation, just because there are so many people that have to change their behavior to make an impact. But we can also, we interact as clinicians, as you do in your professional capacity, with people who are decision makers. And we do have the capacity, because healthcare is a big sector and it has a long reach, to potentially influence people's health decisions when they align with environmental decisions, and sometimes serve as educators. So I think people would wonder about that. There's also a question in the chat, which is another thing that we hear a lot about, which is the whole mental health component of this. So you've given us a talk today that's very realistic and it's very long range. And I don't think there's any doubt for anybody that, you know, is in this field that things are going to get a lot worse before they get better. How do you counsel your students, and how should we counsel our patients who are really upset about this, particularly young people?
So I think, well, I have two answers to this. And one we talked about a few weeks ago at the Center for the Environment. I think you were at that dinner. I think young people's engagement on this has been such a positive and delightful part of this problem. I think young people have provided some of the energy for change that we're seeing in the US right now. I will say a couple of things though about that. One of the phenomena I see in my class is despair. People see, when they actually study it and they realize how difficult this is, they throw their hands up and say, I'm going to go work on something else because we're just screwed. And I think that's, I feel an obligation to keep that from happening. Unfortunately, I hear a lot of people do it in a frankly delusional way. They say, oh, we have to give people hope. I have some colleagues who've been pretty high level advisors to the President of the United States who've said, we have to give people hope. We have to tell people the good news. There's a program at Harvard that publishes a letter called The Climate Optimist, and I find that offensive, and I'll tell you why. If you have to tell somebody that they have a terminal disease of some sort, chaplains in the hospital are not trained to tell them, oh, it's going to be okay, because it's not. I actually think, and you know that I'm having these discussions with a professor of divinity and a minister at Harvard about the idea of grief. How do we actually talk about grief? How do we confront the reality of climate change and what it's going to mean for the world, the inequality of it, the cruelness of it, the suffering that we see in the US, but also even more around the world in vulnerable countries. But not let that grief paralyze us, that we actually still live our lives and try to make the world a better place, realizing that whatever loss we will have, it's never too late to actually save what we have. To try and save what we have will mean making the world better, even if we still inevitably lose something. And I think that's the reality of climate change that we need to come to grips with. And I think thinking about this as grief is to me at least, a way of finding real hope, not delusional hope, through rhetoric. I will say one other thing, that because I know it's 12:59 and we have to end in a minute. There are a lot of exciting things going around at Harvard in our community related to climate change and health. My friend Sam Myers runs the Planetary Health Alliance, and it's an incredibly exciting program. And there's a big conference in 2 weeks on October 31st to November 2nd. And people should think about attending that and listening to physicians like Sam thinking about how to deal with this. I don't have all the answers. I do think that sometimes there's well-intentioned, but not necessarily the most appropriate responses to this. I think this needs to be a continuing conversation, and I think we should all have a certain amount of humility, because the future is going to be different from what we have had in the past, and we have to be prepared for that. And that means all of us need to be able to admit one concept. People don't understand that it's cumulative emissions. So zero is just a number. When companies say, oh, we're net zero, I'm like, yeah, did you pay for all the last 100 years of your emissions? You know, like zero is just a number. You know, in the US, since we put out a quarter of the CO2 in the world for the whole world, we need to be negative. Now, I don't think we're going to be. You know, we owe the world, if you count carbon dioxide as $100 a ton, US owes the world $50 trillion. We're not going to pay the world $50 trillion, but that's the level of that anger you're beginning to see in the rest of the world, in Pakistan, in sub-Saharan Africa. And I wouldn't be surprised if in this COP meeting coming up in Sharm el-Sheikh in November, we hear a lot of angry calls for the rich countries of the world to pay much more attention to and pay much more money to poor countries of the world to deal with this problem. It's not something we have any political will to do right now in the US. And I think that's unfortunate.
Well, Dan, thank you for opening our eyes. And while you say we shouldn't have false hope, you've given us some means forward. I do feel that healthcare is a very visible profession for the general public, and things that we do that advertise that this is a big problem that we all need to take seriously, I think can change the needle in people's attitudes. There is some research that supports that. But I agree that we need to understand the problem and where the bigger impacts are. So I am going to thank you from the bottom of our hearts. I'm going to turn this over to Sue Ellen to talk about our next meeting. And I know Dan is available at Harvard. If people want to send him emails, he's findable. If you want to argue with him, I always learn from him. So thank you, Dan.
Great. Thank you, Tina. Thank you, Dan. That was you were able to distill a lot of complexity into what I would call a common sense perspective. So much appreciated. I would also add that this is a problem for all healthcare professionals. We all need to get involved, and we all have to play a role in addition to our physician colleagues. Our next webinar will be Wednesday, November 16th from 12 to 1 Eastern Time, and the speaker will be Jamie Hart, who's an associate professor at the Harvard T.H. Chan School of Public Health. She will be talking about the Nurses Health Study series and focusing specifically on Nurses Health Study 3, which looks at environmental exposures on disease risk. She's also very interesting and engaged in this work, and we hope that you'll be able to join us next month. So thank you, everybody. Thank you for coming, and we will see you next month.